In the fall of 2017, the U.S. Navy created the first ever Unmanned Undersea Vehicle Squadron, or UUV RON 1. This squadron will spearhead the service's development and deployment of unmanned underwater vehicles, or UUVs for short. Over the next few years, more of these devices will enter the fleet to work alongside humans. There are even ongoing efforts to launch UUVs from Virginia-class submarines to conduct surveillance or deliver payloads. UUVs will never replace manned platforms, but they will be used on missions too dangerous to put men on, or missions that are too mundane and routine but important, like monitoring. Champions of UUVs hope they'll help mitigate the looming submarine shortage that the U.S. Navy is facing in the near future. The use of unmanned technologies is not a new concept, but the future development and use of UUVs will influence the U.S. Navy's ability to operate in the vast oceans of the world. However, using unmanned underwater vehicles in marine applications provides some challenges such as noisy communication, position uncertainty, and the likelihood of equipment failures. Even with major recent advances, the unmanned underwater vehicle field is still an emerging sector. Missions such as persistent surveillance, anti-submarine warfare, oceanography, and mine countermeasures are amongst those where UUV capabilities far exceed those offered by other platforms. UUV use is very cost effective. They offer persistent and data quality that are not achievable using traditional methods. This usefulness is even more reflected in remote environments where deploying personnel is a very costly alternative. The U.S. Navy has identified 5 major benefits to using modern unmanned vehicles in maritime surface and subsurface applications. Unmanned vehicles are far less expensive to operate and maintain than manned vehicles. Automated sensors are able to maintain near constant awareness and coverage of an environment. Near constant surveillance means persistence in data collection, enabling a better understanding of long-term behavior patterns and trends. Unmanned platforms also promise to improve productivity, as they allow manned platforms to pursue tasks elsewhere. And unmanned platforms keep human sailors and expensive manned platforms away from danger. 9 areas have been identified as different applications and missions where UUVs can support or conduct a mission. Number 1 is I.S.R, or Intelligence, Surveillance, and Reconnaissance. I.S.R is important not only for the traditional purpose of intelligence collection, but also as a precursor and enabler for other missions and applications of UUVs. The I.S.R mission area encompasses collection and delivery of many types of data: imagery, acoustic, water profiling, target detection and localization, and mapping. UUVs can be launched from a platform of opportunity, such as a submarine, surface ship, aircraft, or even a shore facility, and then proceeds to the designated observation area. The information collected is either transmitted back to a relay station on demand, or when self-queued, such as when the vehicle records a threat change or determines that transmission is necessary. Mission number 2 would be M.C.M, or Mine Countermeasures. M.C.M is perhaps the most problematic of the missions facing UUVs. The proliferation of mine types, their availability to potential adversaries, their ease of employment over a wide spectrum of water depths, and the nature of M.C.M operations, where there is no tolerance for mistakes, combine to make the M.C.M. missions one of the most challenging. Basic M.C.M. mission requirements are: 1. Reconnaissance, which includes detection, classification, identification, and localization. 2. Clearance, neutralization, and breaching. 3. Sweeping, mechanical and influence. 4. Protection, spoofing and jamming. The number 3 mission, I.S.R, or anti-submarine warfare. The objective of I.S.R is to patrol, detect, track, and hand off adversary submarines using UUVs. The 3 major categories of I.S.R are: Number 1. Hold at risk, the monitoring of all submarines that exit port or transit a choke point. 2. A maritime shield, clearing and maintaining a large maritime forces operating area free of threat submarines. 3. Protected passage, clearing and maintaining a route for a maritime force from one operating area to another free of threat submarines. In the future, the mission of I.S.R could see the rise of an autonomous approach to the problem. Application number 4, ID, Inspection, Identification. This mission stems from the need to efficiently inspect ship hulls and piers for foreign objects such as an explosive device to keep harbors and choke points safe. Mission number 5, Oceanography and Hydrography. Currently, UUVs are revolutionizing oceanography. They have been widely used for in situ measurements, which would be difficult, expensive, and in some cases impossible to attain by using traditional ship-based sampling techniques. Mission number 6, CN3, Communication Navigation Network Nodes. The CN3 capability is a support function enabling other systems to perform their missions more effectively. Its objective is to provide a low-profile communication and navigation relay function for a wide variety of platforms. The advantages offered by using a UUV include extended standoff distances and greater accessibility. CN3 will provide submerged communications to undersea platforms in areas not otherwise available. Mission 7, Payload Delivery. Payload delivery is necessary to support a number of other mission areas by providing the energy, navigation, autonomy, and payload deployment systems. Mission number 8, IA, or Influence Activities. The objective of IA is to deceive, deter, and disrupt enemies. 2 IA roles are well suited to UUVs. First, as a platform to jam or inject false data into enemy communications or computer networks, and second, as a submarine decoy. And lastly, mission number 9, TCS, or Time Critical Strike. UUVs can provide low-risk, high-payoff augmentation to strike missions, providing an ability to covertly deliver weapons to close-in launch points. UUVs are military equipment that can be used to covertly detect and engage in enemy harbor areas or under enemy waters. It is expected that UUV systems of higher performance levels will be developed in the near future. UUVs will fundamentally alter the way war is being fought. Regardless if it's the shallow waters or deep sea waters of the enemy's territory, UUVs will be increasingly deployed to conduct highly dangerous missions that have never been possible by legacy naval systems. Major countries around the world already see the potential of UUVs in maritime warfare and continue to develop them into a higher level. Such a trend will continue into the foreseeable future.